All right, guys, now that we've made our graphs, we're going to analyze this data. There's a couple of things that we're going to need to get from this, from each one of these moons. I'm showing you Europa, but you have to do this with all of them individually. So you're going to look at each one of your graphs. It's probably easiest to do this using the graph right from your Google Sheets file, because you can actually look at individual points on here. So if you look at your lab and you go down to where it says part 3, there's two columns here that are kind of highlighted in gray. These are the two numbers that we need. We need the period and we need the amplitude. The period is the time it takes for the moon to go all the way around Jupiter. And we can analyze that, we can figure that out by looking at from peak to peak. So right here to right here is the time it takes for Europa to go all the way around Jupiter. And again, from this peak to this peak to that peak, each one of these from peak to peak is the time it takes. You could go from peak to peak or from the valley to the next valley. Both of them will be the same. If I click on the very top there, it'll actually tell you that data point is day 6, and it's at a value of 4.5 Jupiter diameters away. Okay, so that's day 6. If I click on this one, that's day 10. If I look at this one, that's day 13. Okay, and if you look at this one, that's day 17, and then this one is like a little bit off the peak, but that's day 20. So you can kind of see, if you like do an average, they're about 4 days apart. So 4 days, I would say approximately 4 days would be the time it takes for Europa to go all the way around. So that's the period of Europa. And so what you would do is you type that number in here. That's 4 days. Okay. The amplitude, and I did Europa, don't forget. Okay. The amplitude is how far does it go away from Jupiter? Okay. In other words, if you were to kind of consider a drawing here. So if this is Jupiter, okay, and Europa's, well, that was terrible. That's a weird looking circle. Okay, that's Jupiter. But Europa's like way over here. The distance from Jupiter out to that point, okay, is the amplitude. And it's also the diameter, or sorry, the radius of its orbit. So if you consider that this is going all the way around, so here's Europa going around Jupiter like that. That is the diameter of its orbit, or sorry, the radius of its orbit. Okay, so that's essentially what we're trying to figure out, is what is this radius of its orbit. And if you look from here up to the peak, that's the amplitude, and it says 4.5. For this one, 4.2. This one, 4.05. This one, 4.6. So you're just going to take an average, I would say, somewhere a little bit above 4, maybe 4.3. You can add these all up and divide them by however many you do if you want to get really, really accurate. And that's your amplitude. And you can do it down to the bottom here. It's somewhere around 4. Okay, it might be worthwhile going through all of them, but I would say about 4.2, let's say, Jupiter diameters away. That's the semi-major axis. In other words, that's the radius of its orbit. Okay, and so you just type that number in there, or write that number in there. Okay, and so you're going to do that with all 4 moons, and just put those numbers in there, and that's part 2 of the lab. Okay.